Hi everybody, my name is Veronica and today we're learning about structures. Take a look at these pictures. What do you notice? That's right, they are all bridges. Where can you find bridges? Well, bridges are found everywhere. They can be over highways, they can be at the park, they can be over rivers, everywhere. And what makes bridges so important? Well, bridges are structures that people use to cross over open spaces like valleys and rivers, and bridges have roads and pathways that people use to cross over to get to one place to the other. Bridges have been around for thousands of years. They've been made out of rocks, out of stone, out of mud, but today we use metals, concrete, and even glass. But the materials are not what makes bridges strong. The bridge's strength comes from their structure. There are many types of bridges around the world. Some are held up by cables, like this one, and there are some that are held on top and underneath, like this one. Today we are going to be engineers, and your challenge is to make a bridge out of weak material like spaghetti and make a structure strong enough to hold some books up. Before we begin, let's talk about what makes a strong structure. Take a look at these pictures. What do you notice? What shapes do you see? That's right, triangles. When you put pressure on one side of a triangle, let's pretend this one, it will bend. But if you put pressure on the tip of the triangle, it will keep its shape. That's why you often see a long train of triangles in bridges, and they're called truss. And today, that is what we are making. Today you'll be needing some dried spaghetti, marshmallows, rubber bands, a marker, cardboard, scissors, and some books for weights, and also you'll be needing a partner.
The first thing we need to do is sketch our truss template. As you can see, spaghetti is very fragile. You need more layers to make it more sturdy. In order to make the beam stronger, we bunched up about 10 noodles together and tied them up with a rubber band. Here you can see us assembling our beams. At the beginning of the experiment, we noticed that the mini marshmallows and the single noodle were too flimsy, so we decided to use a glue gun to secure all the materials together and act as a joint. Here you can see us assembling the truss of our bridge. Also notice that we lowered the center of gravity, that way our bridge is more stable. This is what one side of the bridge will look like. Now comes the hard part. Now we have to attach both sides together at a 90-degree angle. To make our bridge more secure, we added more truss to it.
This is our final product. As you can see, there are many truss incorporated in our bridge. And due to trial and error, we have to switch from marshmallows to hot glue. So now we will test our bridge. Let's start with one book. Okay, let's start with 2. 3, 4. Get the 5th one. Let's try 5, 6, 7, 8, 9. 9 books. Wow. What else can we put? Let's get that bottle. Well, this didn't work.
By conducting this experiment, we learned that structures like bridges have both form and function. Bridges are a critical component of our nation's infrastructure, making it possible to ship materials from factory to factory or facilitate travel so consumers can purchase goods as well as go into other communities. We also learned that bridges' strength comes from its structure. Structures are also in turn affected by forces that act on them. As we saw in our experiment, the bottle was too heavy and therefore our bridge collapsed. In conclusion, structures need to be strong and stable to be useful.